Alright, this is Mr. Gillum, and today we're looking at an example in your practice and problem solving book from lesson 6, day 3 on page 63. Steve said that 4/3 divided by 1/6 equals 4/6. How do you know without dividing whether Steve's statement is reasonable? Justify your answer by showing how to find the quotient. Use numbers, words, and models to explain your answer. So there's a lot of parts to this. Let's just start with part number 1, and that is, how do you know without dividing? Those are the key words, without dividing, whether Steve's statement is reasonable. Then we'll go on to justify. But let's start with that first question. How do we know that that is not or is a reasonable answer? It says Steve said that 4/3 divided by 1/6 equals 4/6. So here's what I know. I know that I divide any number divided by 1 is that number. It doesn't change. Okay? Anytime I have a number divided by 1/2, twice as much, 1/2 will fit into any number twice as much. So it'll be 2 times the number. Anytime I have a number divided by 1/4, I know it equals 4 times the number, 4 of the number. Here's how I know this. Any number divided by 1 is a number. 1/2 is half as big as 1, so twice as many fit into the same number. 1/4 is 1/4 as big as 1, so 4 times as many will fit into the same number. And so what I see here is 4/3 divided by 1/6. Well, I know that 4/3 divided by 1 is still 4/3. And I'm dividing by a number much less, 1/6. So it should be 6 times as much. And I see that we're getting an answer of 4/6. Now I know that 4/3 without multiplying it by anything is already bigger than 4/6. So I know that his answer is not reasonable. Okay, it should be 6 times as big as 4/3. And it's already smaller than 4/3, being 4/6. 4/3 is actually greater than 4/6. So I know his answer is not reasonable because his answer should get 6 times as big. And 4/6 is actually smaller than 4/3. That's what I'm trying to get out. So I hope that made sense. It's kind of a difficult thing to understand with words and no model. So I'm going to explain that again with the model. But I know it's not reasonable because of this reason over here. Because I know that when you divide a number by a fraction smaller than 1, it should get to be a bigger number, not a smaller number. I think it says somewhere on your orange text in your example, kind of explains that in the book's own way as well. The next part says justify your answer by showing how to find the quotient. And so that's this, justify your answer. All this has to go with the show your work portion. So it says use numbers, words, and models to explain your answer. So let's start with numbers. 4/3 divided by 1/6. We need to figure out what that does equal because it does not equal 4/6. So, I mean, that makes no sense at all. We know the keep, change, flip method, so we can keep the 4/3, change the to multiplication, and flip the second fraction. When we multiply straight across, 24/3, 24 divided by 3, or 24/3 reduced, equals 8. So I think the answer is 8. Over here, if I multiply it up here as well, you can see that when I was explaining this, it'd be 6 times as much. That's what happened here as well. I'm multiplying by 6 instead of changing it to something else and getting a smaller answer. So I think the answer is 8. That would be numbers. I'm going to leave the words since I got kind of the sloppy handwriting. I'm going to leave the words to the example. You'll have to read through that, and I'll pull that up here in just a second. And then the models to explain your answer. The models are going to be important because you can always use a model to find the correct solution if you're good at using models. So we're trying to figure out what 4/3 divided by 1/6 is. And here's how I'm going to use my model. I need 2 number lines. The first number line is going to represent 4/3. So I'm going to start with 0 here, and I need to decide how big I need to make this number line. I know 4/3 is an improper fraction. 3 goes into 4 once, and a little left over, 1/3. So I need to actually have 2 whole numbers on my number line. 1 and 2 because 4/3 is somewhere between 1 and 2. I'm going to divide the top part of my number line into 1/3 pieces. So do that as accurately as I can. And 4/3 is represented by 4 1/3 pieces. So 1, 2, 3, 4. This is the 4/3 mark on that dash. That's 4/3. That's representative of 4/3. That's where the 4/3 mark is on the top number line. On the bottom number line, we're going to represent 1/6. So instead of dividing it into thirds, we're going to divide it into sixths. So I'm going to try to do that the best I can here. Okay, and so I need to know how many 1/6 pieces fit into 4/3. So 1/6, if it said 2 6 pieces, it would be every 2 gaps. For every 3 6 would be 3 gaps. So, but this is just 1/6. So the first 1/6 would be there. 2, 3, 4, 5, 6, 7, 8. So with the model, you can see as well, I know that 4/3 divided by 1/6 equals 8. 8 1/6 pieces fit into 4/3. As I'm looking at the example in your book on page 63, it basically explains in words, like using sentences, what we talked about. It says that Steve's statement is not reasonable. The division 4/3 divided by 1/6 asks how many sixths there are in 4/3. 4/3 is greater than 1, and there are 6 sixths in 1. So I know there must be more than 6 sixths in 4/3. That means the quotient must be greater than 1. It could not be a fraction less than 1, such as 4/6. I tried to explain that, and it's difficult to understand, but I hope I did a good job and you understand what I mean by that. It says I drew a number line in the model to find the quotient. The top number line is divided into thirds and shows 4/3. The bottom number line is divided into sixths and shows that there are 8 sixths in 4/3. So 4/3 divided by 1/6 equals 8. And that is something that we got as well. It looks to me like there's only one problem on the back of your practice problem solving paper, and so you can see from the front example that it's going to take a little bit of work. It's not just a 1 or 2 part answer or just a simple explanation. I mean, you need to do a good job, and on the side it even prompts you to use numbers, words, models to explain your answers. So it needs to be modeled similarly to this video or the front of your practice and problem solving paper. And that's it for today.